I hope I've given you some outline of the ecosystem, other ecosystem, and then, as I mentioned to you, you'll find similar issues with almost any system of reasonable complexity. Okay, and so in a sense, there are just too many research problems on this. That's what I want to say. So don't hesitate, just dive in, take us any particular system, you'll find problems. Okay? For example, you can have a health medical device, for example, what's called insulin pump. And if the insulin pump, the instructions can be sent through Wi-Fi or it can be managed through a mobile, then you can see that there could be some problems in there itself. Okay? There are other problems, but at least you can immediately see there's a problem there itself. Okay, so let's quickly look at best practices with respect to writing proposals. I was asked to speak on this a bit. I'll just briefly talk about this. Okay. Again, I thought nothing better than start with a shloka. And this is, you might have heard about this shloka. Alpakshara asam digdam saravat vishuto mukham asthobam anavadyam cha sutram. Sutra vidu. What is it saying? A sutra is basically alpaksharam. It should be have brevity. It should be not too, it should not go on and on and on and on. The sutra should be concise. Asadingdam. Okay, this one. It should be non-confusing. Sarvat. It should be contentful. It should not be just talking about all kinds of things without any connection. Right? Saravat. Vishuto mukham. Should have wide applicability if possible. Okay. Wide applicability. Asthobam, it should not be full of pauses or junk. Okay, okay. Basically, sthoba is basically stoppings. It should not just stop here and do something else and then come back to something else. Okay, okay. Anavadyam, it should not be disputable. Whatever your proposal is there, hopefully you're making the right statements. Okay, so I'm just sutra in Sanskrit tradition is supposed to have these properties. Should be concise, should not be confusing, should be full of content. It should be of wide applicability in all kinds of domains without any junk and should be really non-disputable. I would say a research proposal should also have these aspects. Okay, so let's quickly look at it. Basically, it should communicate intent clearly. Okay, now there are many types of research proposals you can have. You can propose to research something new. You can propose to reconfirm already published work, or you can actually try to show that already published work is something is wrong with it. That also is perfectly fine as long as you do it rigorously. It can also be even other things, like for example, provide new data sets, benchmarks that can be used for other researchers. Even that is a perfectly fine. Again, if I think about first part, propose to research something new, it can be novelty is important because you are saying I'm going to do something new, right? You said you're going to do something new, then you better have novelty as a product. Again, the novelty is respect to what? Is it with ideas and insight? Is it the fact that you use different materials? Is it because you reduce the cost? Is it because it's a different production process? Of course, in security, it might be slightly different. But in, for example, mechanical systems, it could be production process, or it is in the user context. Is it a new user context? Okay. It could also be novelty with respect to whom, for example. For example, it may be that somebody has done this somewhere in some other part of the world, but it's not been done in this part of the world. Okay. For example, the fact that you have a unique ID, right? It is there in many parts of the world. But on the scale that was done in India, it has not been done anywhere else. Okay, so it is novel from that point of view. Okay? Or for example, somebody has done a lot of quantum experiments in other part of the world. It has never been done in India. So if you do it, that also is interesting because we want to have local capacity. We want to also be able to do it ourselves. Okay? Again, one more thing to repeat the same. It need not be foundational. It can be applied. The novelty could be in application or in system integration. Okay. Again, there could be a distinction between engineering and science. Typical engineering usually means that is directed towards satisfying human or societal needs. And again, there is a connection between that and I think you might have heard about patents and essentially do something new. It's sort of connected with what is patentable also. And for example, patents say that if you want to patent something, it has to be non-obvious and also advance useful arts. What it means by useful arts is essentially it has to be useful in our societal context. There has to be some kind of engineering aspect to what is being done. Okay, so that's one part of the thing. Another thing I mentioned, propose to reconfirm or to disprove something. Okay, and this is quite useful also. For example, one of my students discovered that there is a data set used in a particular domain, and somebody is collecting information about some event, and they are using it with the clock of the system. And the clock is 32 bits. And if you actually calculate it at current clock speeds, in 32 bits actually rolls over within about 2 or 3 days. Okay, because 2 to the power of 32, if you multiply by some 100 nanoseconds, whatever, you'll find that 1 day is easily 32 bits are not, usually exhausted in 1 day. Okay? So somebody collected a lot of data for 6 months using a 32-bit clock. Okay. Now you can see that something is wrong with it because they didn't realize that it's a oversight. They didn't realize that in one and a half days or so, 32 bits are gone if you use the computer's local clock. Okay? So my student was working on it and discovered finally that this is a bit wrong. And this, unfortunately, this data set was widely used by many parties in the research community. So even finding that this bug is there is an important issue. So if you're able to find bugs in data collected or inconsistencies, that also is interesting. Another thing that could be interesting is provide new data sets, benchmarks that can be useful for other researchers. For example, if you are working in the biometrics area, suppose you come with a bunch of very good biometric, let's say, raw material, okay, which can be used for validating how good a particular system is, like with respect to classifying the images of some of the biometrics. Okay? Okay, so those kind of things also can be useful. Okay. Again, if I'm writing a proposal, you should clearly indicate what is novel in a proposal, have a section on current state of the art, both locally and globally, and also mention in what way is it advancing state of art. Again, you should also mention clearly, is it a model or abstraction of a real system? Or is it a life system itself you're targeting? Okay? Are you using a simulation partly or fully? If you're using simulation, how do you propose to validate it? Again, if you're using a live system, is it ethical to work on a live system? Does the data collection strategy compromise the privacy itself? Is it necessary to attack a learning system to show its flaws? Okay, discuss if this is appropriate. Is your project science or engineering? Okay, I already mentioned this. So you should have a section on how your research proposal can probably help. Okay, and again, after describing all these things, once you do your research, what new insights are likely to come from research proposal, from simulations, from the new data that you come up with? Can you interpret the new data? Do you have to report critical findings to regulatory bodies before publication? That is, there is sometimes the government and other kinds of bodies will require you to keep it confidential till they have looked at it, okay, because for other reasons. Okay. Again, you also might have to talk about in a proposal what kind of things you need. Do you need equipment? Do you need data from some particular governmental bodies, for example? Do you need permissions or approvals? For example, if you're doing some research on drones, you may want to get approvals to be able to operate the drones in the first place. Okay, things of that kind. Okay, one other small little advice I would give is to avoid incorporating fashionable themes in your proposal unless you are clear about their value in the proposal. I'm pretty sure that you're thinking about it carefully, but sometimes I notice some themes which are completely inappropriate. They get put into the proposal because people might think that your proposal might have a higher chance of let us say getting accepted. I would recommend someone to avoid it if possible. Okay? And also in a proposal, also it's better if you are able, if you're clear about what should be out of scope, okay? What you don't want to consider, clearly demarcate it so that you are clear about it, and the proposal evaluator also is clear about it. Okay? Again, I'll close in a few minutes. Again, suppose we specifically take into account security research, I just mentioned a few things. It's best to discuss your assumptions. For example, your system boundaries, the various actors and entities in the system. What are the attack models you're assuming, including capabilities of user and attacker? What are the obvious defenses? And what are the kinds of weaknesses assumed? For example, in vulnerability research, for example, many attacks assume program error first. And then because somebody has made a program error, that is used as a way to actually essentially augment the problem. Basically, they used to compromise the system furthermore. That is, there's a small error, how to magnify it so that finally you take over the whole system. So basically that assumption is made. Okay? Suppose you assume that there's no program error, then of course that whatever is being proposed is not going to be feasible. So you have to be clear that you need to have this kind of minor bugs, program errors, then I'm going to able to take over the system. We also have to mention it very clearly. Okay? What are the system models? Are you doing full-scale live systems, part of it, or simulation? Or nowadays there is something called digital twins. There are part of it is simulated, part of it is emulated, and part of it is the real system. And there is some kind of transfer functions between the emulated system and the real system. And then, so what are the interaction between these components? Those kind of issues also you might have to specify. And at an even more abstract level, use your work at the protocol level, basically at the level at which you're communicating messages between various entities in the system. Is it at the mathematics or cryptographic kind of levels? Okay? Or is it the systems level? Basically, you have various systems that are interacting in some particular way. And basically because of system level issues, for example, reliability, because some failure issues, is that reason why the system is not working well? Or is it because of societal issues? Basically, once you introduce the human beings into the picture, they might misunderstand the system in particular ways, and therefore there could be issues. I think in the previous talk, there was some discussion about how somebody took away all the money from a particular account, right? Or this is the level at which you want to investigate a problem. Okay? So I think I'll skip this particular slide to cover. So I'm just giving you one example of if you just don't want to think about a technical level deeply, you want to think at a security level, you can think about this problem. Okay, purely based on survey-based research. I'm just giving an example. Suppose I want to do what is called usable security or privacy. Okay, means you are interested in figuring out there is some security model, or the society are people able to use the security model or the privacy aspect of it? Are they able to use it? Okay. For example, do people keep the Aadhaar number guarded closely? Do they give it to anyone who asks? Okay. Do you experience failure of authentication at times? Do you have information about that? Do people know about the linking problems? Do they use virtual IDs? Because virtual IDs is the part of the Aadhaar. Okay. Do people use it? Do people, again, there is some very interesting issues here. At enrollment time, it has been noticed that people give the same phone number for two people in the family to enroll. Actually, it turns out people are even given the same fingerprints, okay, for grandfather and father and son, because they want to make sure that the pension comes through without too much trouble, all those kind of things, okay. So there are various kinds of issues that happen in society, okay. Do you want to research those kind of issues, okay? So there are mathematical problems you can look at. You can look at a system level problems you can look at. You can look at, let us say, deeper issues about security policy itself, okay? And there are even issues like your address changes. How many people will actually update the address with the Aadhaar, for example? Does it create problems that your address is not valid? Okay. And similarly, for example, there is income tax people. They tell you that you have to get it linked. How many people do it? So the thing is, you can come up with a certain research. I'm just suggesting one type of research. There are varieties of types of research. Even this is good research if done properly and well, so that you can figure out what kind of security features or privacy features that there in a system people are actually using, and what things people are not able to use. So then it might give you some insight into what should actually be the new system be like. Okay, so that you can make the system more robust. So there are a lot of other possibilities. I think because of lack of time, I'm going to stop here. So there is, I think the whole wide world is at your, it's available for you to think about as from a security point of view, the kind of problems that are there, and you can actually, if you think systematically and more deeply, it's a really kind of problems. Okay, with this, I think I'll conclude. Thank you.
Thank you so much, Professor Gopinath, especially for sharing tips on how to write a good research proposal and also the potential research problems. Our next speaker, I know we are slightly delayed, but thanks for your patience. Our next speaker is Mr. Prabhakar Malya. Welcome, sir. Let me quickly introduce you to the attendees. Mr. Prabhakar Malya was the Vice President, Head Security, Audit and Architecture at Infosys Limited. He received his master's degree in computer science engineering from the Indian Institute of Technology, Madras. Prior to his tenure at Infosys, he worked as a senior development engineer at BHEL, Bharat Heavy Electricals Limited. We are happy to have you join us today, sir. Malya sir will be speaking on the cybersecurity top concerns, its impact in the cyber world, and he'll also be covering secure coding issues. Over to you, sir.
Thank you. Okay, and earlier I think Dr. Dattatreya Kulkarni was a bit apologetic about having left academics to join the industry. He's in well, I'm keeping him company, more than company, because I've only been in industry, and over and above that, I'm not even a PhD or a doctor. Okay, so